Welcome back to our lesson practice review. Today we go through 3.04. Our lesson kind of covers us taking two polynomial expressions and adding, subtracting, or multiplying them. And we show that we get another different polynomial when we do that. So when we're adding or subtracting, we're really just combining like terms. And this is really good teaching to have all the different color coordinations to see anything that's cubed, we put those together. Anything that's squared, we put those together. Anything that's to the power of 1 or any constant. And so the colors is very helpful. I will do my best to continue that. When you're multiplying, though, it's really just kind of our box method again, our area model where we multiply out. And we see that we can combine like terms. If we end up getting, for example, two different terms with x squared, we can combine those. So to start us off, we have problems 1 and 2, which we're asked to write each function as a sum using the fewest number of terms. And so when I go through this, I am going to start with the highest exponent. I'm always going to put it in terms of descending order. So in the far left one, I see x squared as the biggest. And the far right one, I have a larger one, which is x cubed. So the only x cubed is just 3x cubed. Next up, to the power of 2, I see that we are adding these two together. So 2x squared plus a negative 5x squared is negative 3x squared. Then we got power of 1, negative 7x plus a negative 11x is negative 18x. And then lastly, we got positive 4 plus positive 2, which is just 6. Next up, we have number 2, which is b of x, and we're subtracting. And so there's two different ways that you can do this, and we may have talked about this in class. I'm going to leave it as subtraction, but if you wanted to just change it to addition, you could just distribute the negative into this and then change it to an addition problem. So it would end up becoming the same thing, 2x squared minus 7x plus 4 plus, and then each of these terms would just switch signs here. Run out of room. 5x squared plus 11x minus 2. And so then we would just do the same thing as the original one. You can do it that way, or again, the way that I believe that we kind of talked about in class is just to subtract each individual one. So highest exponent here is power of 3, and there's only one. I should continue with the same color scheme. So 3x to the power of 3. I just realized up here I put power of 2 by accident. The next one here we got is 2x squared and negative 5x squared. I realize these are the same equation, but subtraction. So now I'm doing 2x squared minus negative 5x squared because of the subtraction sign here. So instead of adding them together, I am now subtracting, which subtracting a negative becomes adding a positive, which ends up giving me plus 7x squared. Next up, my power of 1, negative 7x, negative 11. So negative 7x minus negative 11x, which again changes to addition, becomes positive 4x. And then lastly, we got positive 4 minus positive 2, and 4 minus 2 is just 2. Again, if you went through and just added these together, you'd end up getting the exact same answer. There's two different methods of doing that. All right, problems 3 and 4. Fill in the blank with a polynomial that makes each equation true. Okay, so this is a little bit trickier in the sense that we're kind of going backwards-ish. Personally, there's kind of two ways of doing this. I am going to just kind of like move everything to the other side of the equation to see what ends up happening. What I mean by that is if I have a power of 5 here, I'm going to add this plus 4x to the power of 5. And when I do that, I end up getting 12x to the power of 5. And then again, when I kind of look at what would happen here, I would end up getting that positive 8x here. So then after that, I'm going to subtract the 6x cubed subtract the 6x cubed. There is no x to the power of 4 in this one, so I'm just going to put our negative 3x to the power of 4 here. 7x cubed minus 6x cubed is just x cubed. And then I add 9 over here. Looks like, again, I have something that is not in my first term, so I'm just going to have negative 2x squared here. Sorry, I used the same color twice, so let's change that. And then when I add that 9 over 4 plus 9 is 13. So I end up getting what goes inside these parentheses, which is 12x to the power 5 minus 3x to the power 4 plus x cubed minus 2x squared plus 13. And again, if you want to double check that, you could go through and actually kind of add those two together to make sure that it gets us there, but that is the method I'm going to use. Doesn't exactly work for number 4 because in this one here it's subtraction. So if I moved everything over, then all the signs would be kind of messed up here. So I'm just going to kind of take them one by one here. If I'm going from 13x to the power 4 to 15x to the power 4, I'm saying 13 minus what would equal 15. And so that needs to be a negative 2x to the power of 4 to start us off. Then the next one here, our power of 3. So negative 5x cubed minus what would give me 3x cubed. So this one would have to be also a negative, and then this one would have to be 8, because that way when we subtract, this becomes addition, and I get my positive 3x there. So this has to be negative 8x cubed. Next, my power of 2, x squared minus what would equal negative x squared. So this one here, I'd have to subtract 1x squared minus 2x squared. My first set of parentheses here does not have an x value, so I'm just going to leave this one. Oh, it's actually 0 minus what? Oops, sorry. 0 minus what would give me 2x. I still have to do this because now it's got to be negative. So negative 2x here, because then the negative and negative would cancel. So this also negative 2x. And then the last one here looks like I have 10. 10 minus what would give me, and then there is no constant term, so 0. So it's got to be 10 minus 10. So that should give me what subtracts to get there. A little bit of thinking on that one here with our positives and negatives, a little bit tricky, but once you kind of sit down and kind of go through it individual term by term, then it becomes a little bit more straightforward. Number 5, write f of x as a sum using the fewest number of terms. Use the diagram if it helps with your thinking. Yes, please. I'm a big fan of the area model or our box method here. So this becomes x cubed, negative 3x squared, negative 4x squared, and what is this? The 12x. My only like terms here are my corner spots, so I get x cubed minus 7x squared plus 12x, and I'm all done. For number 6, write h of x as a sum using the fewest number of terms. Use the diagram if it helps. Yes, please, again. Only difference here is that I need to make sure that my 3-term one is on the top because the way that they structured this box. X cubed, 4x squared, minus 5. Negative 2x squared and minus 3x here. Multiply through negative 2x to the power of 5, negative 8x to the power of 4, 10x squared, and then negative 3x to the power of 4, negative 12x cubed, and 15x. So when I'm looking for what adds together, I see that my power of 4s are good, but then there are no other terms that I can combine like terms to get. So when I go through this, I just get negative 2x to the power of 5 minus, that becomes 11x to the power of 4 minus 12x to the power of 3 plus 10x squared, and then plus 15x. Number 7, write j of x as a sum using the fewest number of terms. They don't give us a box on this one. I'm going to create my own because I'm going to go ahead and multiply these two together first, and then whatever I get, I'm going to multiply that by x minus 11. So x plus 5 and x minus 8 becomes, when I add these together, x squared minus 3x minus 40. And then I still have this minus 11 in the equation. So I just took j of x here, multiplied these two terms, and then left that x minus 11 on the outside. And now I'm going to be doing what we did for number 6 with a 2x3 box to help me find my final answer. X squared, negative 3x, negative 40, x, and negative 11. This 11 is going to be kind of annoying to deal with, but that'll be okay. Negative 3x squared, positive 33x. What does that do? Negative 40x and positive 440. And so when I combine like terms, the only ones I see are the x squareds here and my power of 1's here. So it becomes x cubed minus 14x squared minus 7x is 33x minus 40x and plus 440. Problems 8 through 9. The function h of x is the product of two polynomials. What kind of function is h of x when I multiply them out? Okay, so I guess in this one here, I could go through and actually multiply it all out. I'm going to use a better method here because when I go through this, what a pattern I want to recognize here is that this first term, when I multiply these together, it becomes negative 2x cubed. That is going to be my highest exponent because it's the highest exponent in this term and the highest exponent in this term multiplied together. And so since those are the two highest exponents, when I multiply them together, it gives me the highest exponent of the product. And so really, this ends up giving me the degree and leading coefficient, everything that I need to know for these next two problems. So yes, you could go through and multiply it out and get it in standard form. Totally doable. And if you want to do it that way, great. I'm just letting you know that this is a little bit quicker of a way to do that. Maybe not after I explain it like that. But anyways, we end up getting a cubic function because it's a power of 3. And we know that since it is a negative coefficient, I'm pointing down, and the exponent is odd, then the two end behaviors are pointing in opposite directions. So as x approaches negative infinity, h of x approaches positive infinity, right here. As x approaches positive infinity, h of x is approaching negative infinity on the right side. Number 10, fill in the boxes with positive integers to make the equation true. So I'm going to, again, use my trusty box over here because I see that there are two terms. We got x squared and negative something, and then x squared and positive something, and then this becomes 12x to the power of 4, and the last term is negative 15. So it's kind of a puzzle here to figure out what goes here. I'm going to go ahead and put, what do I want this to be? Let's try 5 and 3 here to see if that works. In which case, what multiplies to 12x to the power of 4, that could be, what is that, 4x squared and 3x squared, which would then make the insides here negative 15x squared and positive 12x squared. And let's see if that ends up working out. So we got, what is this, 4x squared minus 5 and 3x squared plus 3. And then the insides here, when we add these together, I get minus 3x squared. So yeah, that should work. And again, I think there's a lot of different possible options here, but it just kind of has to work out so that the first term is multiplied to 12x to the power of 4, the last term is multiplied to negative 15, and those middle two terms add up to a negative number, which is the important part. So there may have been something that we needed to switch around, but in this case, it ended up working out. So I will review Problems 10 and 11, whoa, liar. Problems 11 and 12 here asks us to solve each quadratic. So in this one here, before I do anything, I'm going to go ahead and add that 1 to the other side so that it's equal to 0. That way I can kind of go through and solve it from here. The first thing I do when I see three terms like this is maybe trying to put it into the box, because that's kind of my favorite way of solving. And I have to break up this middle term to add to negative 2x, but multiplies to 4x squared. And I try to find that, and there ends up not being anything, which then leads me to believe there's only, completing the square or quadratic formula to solve this. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we got 2 plus or minus, as we simplify, 4 minus 12 over 6. 2 plus or minus the square root of negative 8, yucky, all over 6. And then to get rid of that negative, actually I'm going to do this a couple of things. So this breaks up, I'm going to say square root of negative 1, and then the square root of 4, and then the square root of 2. So if I multiply all those together, I get the square root of negative 8. The reason I do that is because I know that this becomes I and this becomes 2. And so when I rewrite this, I got x equals 2 plus or minus 2I root 2. And now I can use this handy dandy trick of greatest common factor on the top here to get x equals 2 times 1 plus or minus I root 2 over 6, which is just 2 times 3. And then this here, 2 over 2, simplifies because it's just 2 divided by 2. And so my simplest answer here would end up being 1 plus or minus I root 2 over 3. All right, number 12, we got, again, a problem like this. I'm just going to jump into quadratic formula here because I don't know if this factors or not, and I just have a feeling that they're not going to let us do it that nice and easy way. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And as I simplify, this becomes 49 minus 4 times 2 is 8. 8 times 9 is 72. What ugly numbers we got to deal with today. And then x equals 7 plus or minus, and that ends up giving me, what is that, negative 23 over 4. And then this one has only the way that we can simplify it by bringing out the I. Square root of 23 doesn't simplify to anything else. So our final answer here gives us 7 plus or minus I root 23 over 4. And that wraps up our chapter 3, lesson 4 practice. And hopefully we feel a little bit better about not only the quadratic formula, but just simplifying our expressions that add, subtract, or multiply two different polynomials.